I'd like to introduce the basic concepts of sequences and series. We're going to kind of introduce it to you. There are arithmetic and geometric sequences and series. Now, what are all these? Well, they are dealing with patterns. Arithmetic and geometric are different types of patterns, and the word sequence basically is a pattern of numbers. Now, what is the difference between arithmetic and geometric as specific types of patterns? Well, here we go. This type of pattern, if you look at it, arithmetic, the reason it's called arithmetic is because there is something called a common difference. Between each number, there is a difference that is the same over and over again. If you look at these two numbers, okay, what is the difference between those? Hopefully you notice it is a sum of 5. Do you notice how you keep adding 5 over and over again? That would be an arithmetic pattern, is where you're adding or subtracting a common difference each time. What is a geometric sequence? What kind of pattern is that? Well, can you see it here? What are we doing in this pattern? Can you see it? Instead of adding, subtracting something, do you notice between these, hopefully, that you're multiplying by 3? And again, do you see how you're multiplying by 3? Not x3, multiplying by 3 each time. So geometric are when you're multiplying or dividing each term by the previous, by a specific common. It's called a common ratio. They call this a common ratio, that 3. So you're multiplying over and over by 3 for these. So arithmetic and geometric, these have common differences, these have common ratios. And what's going to happen with both of these is you're going to be asked, for instance, to find like the 80th term of the arithmetic sequence. Do you want to keep this pattern going for 80 terms? Be like, no, please no. Well, you're going to learn this rule that generates terms. So you're going to learn how to make a rule, an equation, that you could plug in 80 to get the 80th term. So you're going to run into that. Now for geometric, same idea. What if they ask you for the 10th term? That's going to get huge when you're tripling each time. Well, you're going to learn to make an equation, a rule, that when you plug in 10, you'll get the 10th term. So for both of these, you're going to learn equations to find specific terms. Okay, now, next one I want to talk about are arithmetic and geometric series. Now a series, hopefully you can see here, you have these pluses. So what do you think a series is? Well, do you notice it's basically just an arithmetic sequence with pluses between? Do you see the arithmetic sequence here? What's the difference between these numbers? Aren't we minusing 4? Aren't we minusing 4? Also known as adding -4, right? -4, add -4. See the arithmetic sequence? But with pluses, we're adding them together. So what happens in this situation is they're going to ask you to add up, say, 10 terms. You probably don't want to keep it going and then add them up by hand. So there's going to be a formula where you add up 10 terms. It does it kind of quickly for you if you want to add up a group of terms. It'll always give you how far you want to go to with these. And what you'll notice also is you need that last term. In order to add up an arithmetic series, you actually will need, say, the 10th term. So you have to go back to here with the rule to create the 10th term. Then you have to add up the 10 terms. Anyways, arithmetic series. Well, we're going to do geometric series. So hopefully you can see the common ratio here. What is the common ratio between these? Hopefully you can see you are halving. Hopefully you can see here is you are halving. Also known as divide by 2 or multiply by 1/2. However you want to think of it, you could say I'm multiplying by 1/2. Also known as halving. So that's their common ratio, is 1/2. Again, you can multiply, you can grow or shrink. Now, then with the series, again, you're going to add up terms. So for geometric series, you're going to say add up the first 8 terms. So instead of writing them up and adding them, especially because they're going to be fractions on this one, to kind of get really ugly, there's a formula that you plug in numbers to quickly add up the number of terms. And with geometric, you can do actually add up terms, let's say the 10th term. You could also do an infinite geometric series, and you have an infinite amount of terms as long as it's decaying. That's another thing you could run into with geometric series. So here you're adding up terms, here you're just trying to find the terms. So, and there's a relationship between arithmetic and geometric. You might notice these patterns after a while, that these are kind of like linear functions, y equals mx plus b, and these are exponential growth and decay functions. You'll run into that connection, hopefully, and see there's overlap between them. So that's sequences and series overview. Let me show you a quick real world scenario with these. Let's look at this. Here we go. You make $30,000 the first year, then you make $1,000 more each year. Pretty cool. You get a raise every year. How much will you make on the 10th year, as well as made over 10 years? So made on the 10th year would be an arithmetic sequence. Can you see right there? Can you see? Because if you had made this the first year, second year is $1,000 more, third year is $1,000 more, 10th year. So that would be, right here would be how much you make on the 10th year. We're over 10 years, wouldn't that be arithmetic series? Aren't you adding these all up? And then don't you have to add all these numbers up printed big? You're going to use a formula to do that for you. So that's an example of arithmetic series and sequence. Now, a geometric sequence and series would be if you make $30,000 the first year and then get a 5% raise, cost of living adjustment maybe. How much will you make on the 10th year as well as over the 10 years? So you can see here, if you 5% each year, 5% would be this much the next year. Then third year, you'd be making this much. And on your 10th year, you'd be making that much if you got 5% raise every year. Now, how much you would have made over 10 years, you add all those numbers up. That's really the only difference between sequence and series. You have terms and you add up the terms. You have different functions, different equations for doing all these. There's a different equation that gives you terms, different equation that sums up arithmetic series, different equation for giving you geometric series terms, and then summing up geometric series terms. So there's different formulas you deal with, but they're very, very practical. Hopefully this helps. You understand kind of what you're going to get into, and it's actually a lot more practical than you think.